Let's practice solving quadratic equations by factoring together. While there are some different strategies like taking square roots, using the quadratic formula, or completing the square, in this particular video we're going to be using the strategy of factoring. Okay? We're also going to go ahead and try to write exact solutions, so if we go ahead and get irrational answers or irrational solutions, we'll try to write them in radical form. For number 1, looks like we have this x squared minus 11x plus 19 is equal to negative 5. First thing we're going to do is move everything to the same side of the equation. We want it to equal 0 every single time. Okay, so let's go ahead and add 5 to the left side and add 5 to the right side. If we do that, we're going to get x squared minus 11x plus 24 is equal to 0. At this point, you're going to go ahead and see if you can factor. So I like to go ahead and find the factors of the x squared. And so the coefficient is 1 here, right? So what I'm going to do is I'm going to write 1 and 1 on the side. Those are the factors of 1 for the leading coefficient. And then I need 2 factors of 24 that add to negative 11. So I'm going to choose negative 8 and negative 3. So this would be negative 8x, this would be negative 3x, and those would combine to get negative 11x, right? So at this point, we can go ahead and open our binomials just like this, set it equal to 0, okay? And when we had the 1 and 1, what did that really represent? That represented x and x. So I'm going to go ahead and write it like this. I'm going to write x and x. And then we had a minus 8 and minus 3, so I'll put a minus 8 and a minus 3 here. Okay, so again, this would be our factored form. You can go ahead and FOIL that if you'd like, just to make sure. And now for this whole thing to equal 0, right, then 2 things have to happen. One of 2 things could happen. So for this first one, if you can make this whole binomial equal 0, then the whole thing will equal 0. So in order to do that, you can just set this equal to 0. Okay, so x minus 3 equals 0. And if you add 3 and add 3, we find out that x would equal 3. So if x was equal to 3, then you plug it into the equation, you would get 0. And then you can go ahead and see when this binomial would equal 0. And to do that, just set it equal to 0. So you go ahead and add 8 and add 8. So it turns out if x was equal to positive 8, then the whole equation would equal 0 as well. So these would be the 2 solutions, or where the parabola crosses the x-axis, these 2 locations. Looking at a graph, this quadratic equation would cross the x-axis or have solutions or x-intercepts at 3, 0 and 8, 0. For number 2, we have y squared minus 10y plus 22 is equal to negative 2. So just like in the last example, let's go ahead and make everything equal 0. So I'm going to add 2 to both sides of this equation so that everything is equal to 0. And we have that ax squared plus bx plus c form. So y squared minus 10y plus 24 is equal to 0. All right, so at this point, we're going to try to factor, right? And so the factors of this 1y squared, the coefficient of 1 is just going to be 1 and 1, nice and easy. Then we need 2 factors of 24 that add to negative 10. So I'm thinking negative 6 and negative 4. Those multiply to get positive 24, but add to get negative 10. And I think that's going to work just nicely. So our 2 binomials here, just open them up. And we're going to have 1y and 1y, or just y and y. And then we're going to have a minus 6 and a minus 4. So those would be our 2 binomials, right? Now, what makes these equal 0? Well, for this one, you can set it equal to 0. Y minus 4 equals 0. Add 4, add 4. So you can notice here that if y was equal to positive 4, then the whole thing would equal 0. And then looking in this binomial, you can say y minus 6 is equal 0. And then go ahead and add 6 to both sides. So if y was equal to positive 6, then the whole thing would equal 0. So this parabola would cross the x-axis at 4, 0 and at 6, 0. These would be the 2 solutions, or the 2 x-intercepts for this parabola. For number 3, we have w squared plus 3w minus 12 is equal to 6. Okay, so again, we want everything to equal 0, so let's go ahead and subtract 6 from both sides of the equation. If we go ahead and do that, then we're going to get w squared plus 3w minus 18 is equal to 0. Okay, now we're going to see if we can factor this. The coefficient for w squared is just 1, so we can put 1 and 1. And then for negative 18, we need a positive and a negative, and they have to be 3 apart. I'm going to go with negative 3 and positive 6. This would be negative 3x, this would be positive 6x. Combining those would be positive 3x. Okay, so we can go ahead and open these binomials, set it equal to 0. And we're going to have w and w, or 1w and 1w. One of them is going to have a minus 3. One of them is going to have a positive 6. Okay, if you want to go ahead and FOIL it, go ahead and make sure it works. What makes this whole thing equal 0? Well, either this has to equal 0, so w plus 6 equals 0. Take away 6, take away 6. So if w was equal to -6, then that would be one solution. And what makes this binomial equal 0? Well, w minus 3 is equal to 0, add 3. And so if w was equal to positive 3, that would be a solution as well. So for our two solutions, or two x-intercepts, we have -6, 0, and we have positive 3, 0. For number 4, we have v squared plus 7v plus 15 is equal to 5. Again, in order to solve these or factor them, we'd like everything to equal 0, put it in standard form. So let's take away 5 from both sides of the equation. If we go ahead and do that, we should be left with v squared plus 7v plus 10 is equal to 0. Okay, at this point, we're going to go ahead and try to factor. It's nice that v squared has a coefficient of 1, so we can put 1 and 1. And then for 10, we need two positive numbers because 7 is positive. I'm going to go with 2 and 5. That's going to make 2v and 5v, which makes 7v. And so we're going to go ahead and open up these parentheses for our two binomials. And then we're going to have 1v and 1v. And let's put a plus 2 and a plus 5 inside these. Okay. Now let's go ahead and see what makes these equal 0. So for this one, v plus 5 equals 0. If you take away 5, then if v was equal to -5, then that would be one solution. And for this one over here, v plus 2 equals 0. You can take away 2, take away 2. If you go ahead and do that, then if v was equal to -2, that would be a solution. So our two solutions, or x-intercepts, would be -5, 0 and -2, 0. Those would be the two solutions. Here's number 5. For this one, we have 7r squared minus 14r is equal to -7. In order to factor this, let's go ahead and make this equal 0, put it in standard form. So let's go ahead and add 7 to both sides. If we do that, then we're going to be left with 7r squared minus 14r plus 7 is equal to 0. Okay. Now, before we factor, we should look for GCFs, and in this case, I do see something that should make this a little bit easier. So let's factor out 7 as the GCF. Then we're left with r squared minus 2r plus 1 is equal to 0. Okay, so again, if you have those values that you can see that go into all of them, go ahead and do that, because then you can just factor the inside here, right? So just factor this and just keep the 7 on later on. So r squared has a coefficient of 1 now. That's easier than 7. And then we have a positive 1 and a -2 in the middle. So let's go with -1 and -1. That would be -1r, that makes -2r. Okay, so this is actually a perfect square trinomial. If you notice that we have two identical binomials. So let's go ahead and make this r and r. And it's going to be -1 and -1. Okay, so another way we could write this is going to be 7 times the quantity of r minus 1 squared is equal to 0, right? Because you have two of these binomials that are the same. And then there's actually only one location where this is going to cross the x-axis. We're going to have one solution in this case where you have two binomials that are the same. So if you do r minus 1 is equal to 0, add 1, then you can see here that r is equal to positive 1. So there's only one solution. There's only one x-intercept, and it's going to be at 1, 0. Here's 6. For number 6, we have h squared plus 8h equals -15. Can't factor it quite yet. Let's go ahead and put this in standard form. Add 15 over here and add 15 over here, both sides. If we go ahead and do that, we should have h squared plus 8h plus 15 is equal to 0. Okay, let's see how to factor this. So we have a 1 and a 1 for h squared. And for 15, I'm thinking 5 and 3, just because those make 15, and also add to get to positive 8. Okay, so that was the hard part. Let's go ahead and set up our binomials. And so we're going to get 1h and 1h, and then we're going to have a plus 5 and a plus 3. And there we have it in factored form. What makes this one equal 0? Just set it equal to 0. If you go ahead and do that and then solve, then h equals -3. And for this binomial, you can just use the opposite of what you see in there. So if we see it's a positive 5, it would be a -5, but just going ahead and writing these out just in case. So h would equal negative 5. All right, so the two locations or two solutions would be negative 3 comma 0 and negative 5 comma 0. For number 7, we have 5n squared minus 44n plus 120 is equal to negative 30 plus 11n. Okay, let's go ahead and put everything on the same side of the equation. So I'm going to go ahead and add 30 and take away 11n at the same time. So let's go ahead and take away 11n from here, and let's go ahead and add 30 to the constant of 120. So I'm going 2 steps at 1 here just to save a little bit of space. If you want to separate those, that's also okay. So the 5n squared is going to stay the same. Negative 44n take away 11n should be negative 55n. And then 120 plus 30 should be 150. And this should now all equal 0. Okay. You could try factoring right away, but I noticed that everything is divisible by 5, so I'm going to pull out that GCF. If you do that, you're going to be left with n squared minus 11n plus 30 is going to equal 0. And so I like this a lot more just because we have a coefficient of 1 for n now, for the n squared I mean, and so it's a lot easier, and then 30 is a much smaller number to think of factors as well. So for n squared, I'm going to put 1 and 1, and for 30, I think we need 2 negative numbers because we have the negative 11, so I'm going to go with negative 6 and negative 5 since those do make positive 30, but negative 11 when you add them. Okay, so I think that's going to be our factors. Let's go ahead and open up those binomials. We're going to have n and n because we had an a value of 1, and then we're going to put a minus 6 and a minus 5 inside of these. Okay, so what makes this equal 0? Well, it's going to be the opposite of this. So if you set it equal to 0 and add 5, we're going to find out that n equals positive 5. I'm not going to write out the work for this one. And for this one, it would be n is equal to positive 6. That's what would make the binomial equal 0. Okay, so 5 comma 0 would be one solution, and then 6 comma 0 would be the other solution. For number 8, we have negative 4f squared minus 8f minus 3 is equal to negative 3 minus 5f squared. Okay, we'd like to make everything equal 0, so if we add 3 to the right, we should add 3 to the left. Those are going to cancel out. Then we're going to add 5f squared, and let's add 5f squared on the left side. Okay, so we're just combining those like terms and moving everything to the same side of the equation. Negative 4f squared plus 5f squared is just going to be 1f squared, or just f squared. This minus 8f is going to be left alone, and then it looks like the 3's and negative 3's are going to cancel out, so this is just equal to 0. Okay, so we have kind of this trinomial where we actually don't have a constant, or the c value is 0. And so when you have these ones, we can actually just factor out a GCF of f. So if we factor out f, then we're going to be left with f minus 8 is equal to 0. So this is actually the factored form. Okay, so you don't have to factor the trinomial just because we didn't have that third term. It was just a binomial. Now what makes each of these equal 0? Well, this on the outside, if f was equal to 0, right, wouldn't then the whole equation equal 0? All right, so that's one solution. If you ever see a monomial, then just make it 0. And what makes the inside here equal to 0? That'd be if f was equal to positive 8. Okay, so our two solutions here are going to be 0, 0. So the origin is going to be where one of the x-intercepts are, and the other one's going to be 8 comma 0. Okay, so these ones are actually maybe a little less work. You actually don't have to factor the trinomial. For number 9, we have this 3x squared minus 16x minus 7 is equal to 5. All right, let's set it equal to 0. So we have 3x squared minus 16x minus 12 is equal to 0. Okay, it looks like there is no GCF besides 1, so if we're going to try to factor this, we need to use 3 and 1, a little bit more work here. And then for 12, I don't know, let's start with 4 and 3. One of them's got to be negative here, right? So I'm thinking, doesn't really matter, let's just make the 4 negative. If I go across here, that's negative 12, positive 3. That's going to be negative 9, that's not what we want. This will be positive 9, take away 4, that's going to be 5, that's also not what we want. So let's start over. Let's do 3 and 1, let's do 6 and 2. Okay, and let's see where we should put the negative. Doesn't really matter again, I'll put it on top. 3 and 6 makes negative 18. 1 and 2 makes positive 2. Negative 18 plus 2 is negative 16, so that's what we want, okay? So we now know that these are going to be paired up going across, and so let's go to set up our binomials. Now it's important because a is not equal to 1 that you put things in the correct location. It doesn't really matter as much when a is 1, but a is 3 here. Okay, so the 3x has to pair with the negative 6, so those go on the outers, and that leaves only one spot to put the 2. That's going to go right in the middle here. Now what makes this equal to 0? I'll write out the work for this because it's a little bit more involved. So we have 3x plus 2 equals 0. So take away 2, take away 2. You get 3x equals negative 2, then divided by 3 and divided by 3. So x equals negative 2/3. Right, that would be one solution. So whenever you have these coefficients like a 3 here or something like that, you're going to have a fraction going on here, right? In the future, if you see a plus, this is going to be negative, and you really want this 3 to cross cancel with the 3 on the bottom. So that might be helpful in the future for you to do that a little bit quicker. Okay, this x minus 6, I think you've seen a good amount of these. So if you set it equal to 0, then x would just equal positive 6. I'm not going to write out the work for that one. Okay, there's two solutions here. One's going to be negative 2/3 comma 0. So if x was negative 2/3, y would be 0. And if x was 6, y would be 0. So those would be the two solutions, or two x-intercepts. For number 10, we have 7y squared minus 6y minus 3 is equal to 13y plus 3. Okay, we got to make this equal 0, so let's go ahead and take away 13y, take away 13y on the left side. Let's go ahead and also take away positive 3 and take away 3 on the left side. Okay, if we do that, then on the left we have 7y squared. Negative 6y take away 13y is going to be negative 19y. Then negative 3 take away 3 is negative 6, and this equals 0 now. Okay, so let's go ahead and try to factor. There is no GCF that I see. 7 and 19 are both prime, so very unlikely. For 7, let's do 7 and 1. For 6, let's do maybe 3 and 2, and one of them's got to be negative. So let's make the 2 negative here. That's going to be 21, take away 2, so that's positive 19. So if we want negative 19, let's just make this a positive 2 and make this a negative 3, right? So this would be negative 21 plus 2, which is negative 19. And so we can go ahead and open up our binomials because we found our pairs. And so we're going to get 7y and a normal y, 1y. And the 7's pairing with negative 3, so put those on the outers. Let's put this plus 2 on the inners. Okay. Now let's go ahead and see what makes this equal 0. Again, what you're going to have to do, it's going to be negative because you see the positive 2, and we're going to put 7 on the bottom, so it's going to be negative 2/7. But let me just show you that just in case. So plus 2 equals 0, minus 2 minus 2, so you can see that this becomes negative, right? So 7y equals negative 2, and then you divide by 7 and 7 because you want the 7's to cross cancel, so y equals negative 2/7. Right, after a while you'll probably be able to do that in your head better, but for now it might be helpful to see it. For this one, it's a little easier. Y would just be positive 3. So our two solutions here are going to be negative 2/7 comma 0 and 3 comma 0. For number 11, we have 10m squared is equal to 27m minus 18. Let's go ahead and make this all equal 0. So I guess there's multiple ways you can do this, but I'm just going to go ahead and take away 27m and add 18 to the right side. And I'm also going to take away 27m and add 18 to the left side. Okay, so let's start by doing that just so we can put it into standard form. And if we do that, we should get 10m squared minus 27m plus 18 is equal to 0. Okay, I don't see any GCFs we can factor out, but let's go ahead and try to factor. So for 10, I'm thinking of maybe 5 and 2. That makes 10. And for 18, we need two negative numbers because of the negative 27 in the middle. So I'm thinking maybe 6 and 3. Right, we need two negatives here. So if we go across, that's negative 30 and negative 6. That makes negative 36. If we go diagonal, it's negative 15 and negative 12. negative 15 and negative 12 do make negative 27, so that's our correct pairing. Okay, so we can open up our parentheses and set it equal to 0. And so let's see what we have in here. We're going to have 5m and 2m. The 5m is going to pair with a -3, and the 2m is going to pair with a -6. Okay, so let's see if we can go ahead and set these equal to 0 and solve. Now let's see if we can also do this mentally a little bit here. So for this one, notice how we have a -6. So we know we're going to have a plus sign in our answer, or the answer is going to be positive, right? So see if you can do this mentally with me. We need this 5 to go away, and we want to be left with a 6. So the answer is actually going to be 6/5, right? Notice how if we multiplied this 5 by it, this 5 and this 5 would cross cancel, and you'd just be left with 6. So then 6 minus 6 would equal 0. So try to use that shortcut to save yourself a little bit of time in the future, right? Try it again with me here so it gets more comfortable. If you look at this one here, right, do you see this minus, right? So to get rid of a -3, we need a +3. So m is going to equal, we need a +3. So let's put the 3 on top. And then how are you going to make this 2 go away? Well, you need to cross cancel with something like a 2 on the bottom, right? So if you multiply this 2 by this 3 over 2, notice what's going to happen. This 2 and 2 are going to cross cancel. You're going to be left with a +3, and then +3 take away 3 would equal 0, so that works out. Okay, so if that felt uncomfortable, feel free to write it out, but if you try doing it mentally, I think you'll save yourself a little bit of work. So 2 solutions here, 6/5, 0, and the other solution here is going to be 3/2, 0. For number 12, we have 8r squared plus 21 is equal to negative 59r. Let's go ahead and see if we can set it equal to 0. Let's add 59r to both sides. If we do that, we have 8r squared plus 59r plus 21 is equal to 0. I don't think there's any common factors here, so let's go right into factoring this thing. Let's try 4 and 2 maybe, and then 7 and 3. Everything's positive, so we don't have to worry about that. This would be 28 plus 6 is 34, that's no good. This is 12 plus 14, that's 26, that's no good. We need bigger numbers, so I'm gonna go switch this 4 and 2 to 8 and 1, and keep the 7 and 3. If we go across, that's 56 and 3, which makes 59, so I think we're good to go. Okay. So let's go ahead and open up our binomials like this, set it equal to 0. We're going to put an 8r here in the first one, and then a normal r in the second one, and then we're going to go ahead and put the 8r with a +7, and let's put the +3 on the inside here. All right, so my r's are a little funny. There we go. Let's see if we can use that shortcut a little bit to get these zeros or get the solutions here. So we have this +3. We know the answer is going to be negative. So let's go ahead and put r as negative something. To cancel out the +3, we need a -3 on top, and let's put the 8 on bottom. So those 8s would cross cancel if you multiplied. You'd be left with a -3, and -3 plus 3 is 0. For this one, a little bit easier. R would just equal -7, because -7 plus 7 is 0. So for our solutions, we can say -3/8, 0, and for our other solution, -7, 0. Those are the two x-intercepts. On to 13. For 13, let's say we have 7x squared plus 22x is equal to 8x. Okay, so no constants in this one. So let's go ahead and take away 8x and take away 8x. Still set everything equal to 0. Okay, if we do that, then we're going to have 7x squared plus 14x is equal to 0. Interesting. Okay, so we have a GCF here of 7x, right? So let's factor that out always. If you see a GCF, factor out 7x, then you're left with x plus 2 is equal to 0. So again, we don't have a c value here, so we're ending up with this expression or equation here. And in that case, we have a monomial and a binomial as opposed to two binomials. So what makes this monomial equal 0? Well, it's just going to be 0, and that's always going to be the case. So x equals 0 because 7 times 0 is 0, then 0 times the whole thing is 0. And then what's over here, if x was equal to -2, then the binomial would equal 0. So one of the solutions is going to be 0, 0. We had another problem earlier that looked like this, so if you want to double check and see if they are similar, feel free to do so. Okay, so didn't need to factor this one because it was not a trinomial once you set it equal to 0. Instead, we just factored using a GCF. Okay, let's check out 14. For 14, let's see what we have. We have 35n squared minus 22n plus 7 is equal to positive 4. And so let's make this equal 0. Let's take away 4, take away 4. If we go ahead and do that, we're left with 35n squared minus 22n plus 3 is equal to 0. Okay, so 35, let's maybe start with 7 and 5 for 2 factors. And for 3, we need 2 negative numbers, but it's prime, so it's got to be negative 3 and 1. Let's see here. This is going to be negative 21 and negative 5. That makes negative 27. This would be negative 15 and negative 7, which does make negative 22. Okay, so negative 7, negative 15, that's negative 22. We can set up our binomials just like this. One of them is going to have 7n, one's going to have 5n. 7 was paired with a negative 1, so put those on the outers, and then that leaves only one spot left for this negative 3. Let's try to get these solutions without writing out equals 0, so it's a negative 3, right? So n is going to have a positive 3, and then we're going to have a coefficient of 7, so let's cancel out with a 7 in the denominator, okay? And for this one over here, we have a negative 1, so let's use a positive 1 that we want left. And then to cancel out the 5 as a coefficient, we need a 5 in the denominator. So a fifth of 5 is 1, 1 minus 1 is 0. So we have 2 x-intercepts here, or 2 solutions. One's 3/7 comma 0, and the other one is going to be 1/5 comma 0. Those are our 2 solutions. For 15, we have 15c squared minus 3c is equal to 3 minus 7c. Let's go ahead and rearrange this into standard form. So if we go ahead and do that, we're going to have 15c squared, and then we're going to have a positive 4c. Take away 3 is equal to 0. All right, at this point, let's go ahead and see if we can factor because it's in standard form. So let's do 5 and 3, 3 and 1. One of these has to be negative. Let's make it on the negative 1 maybe. This would be 15 take away 3, that's 12. This would be 9 take away 5, that would be 4. So here's 9, here's negative 5. That does get you the 4 that we're looking for. So we can go ahead and write our binomials now. So in the first one, let's put a 5c and let's put a 3c. That makes our 15c squared. The 5c will pair with a negative 1 and the 3c will pair with a positive 3. Let's see here, for this one, we have a positive 3, so we need a negative, so c is equal to negative. We would like a 3 on top and a 5 on bottom, so the 5s would cross cancel and we're left with a negative 3. For the second binomial here, we have a negative 1, so we would like a positive 1 on top, and we would like a 3 on bottom, so the 3s will cross cancel, and we're left with a positive 1. Now our 2 solutions here are going to be negative 3/5 comma 0, and the other one's going to be 1/3 comma 0. And finally for 16, we have 6e squared minus 13e plus 3 is equal to negative 3. Okay, let's set it equal to 0. Let's go ahead and add 3 to both sides of this equation. If we do that, we get 6e squared minus 13e plus 6 is equal to 0. Let's see, for factoring here, let's do maybe 3 and 2 and another 3 and 2, but it looks like the second 3 and 2 both have to be negative, right, to get a positive 6. And so if we go across, that's negative 9 and negative 4. Oh, negative 9 and negative 4 do add to get negative 13. Okay, so if we go ahead and open these up, it's kind of nice when you get it on the first try. Let's go ahead and put a 3e and a 2e. The 3e is pairing with a negative 3, so make sure you put that over here. And the 2e is paired with a negative 2, so let's put that in the first binomial. Okay, what makes this one equal to 0? Let's see. E would have to equal a positive 2 over 3. So the 3's would cross cancel and you're left with a positive 2. And then for the second one, let's make this one, we need a positive, so the 2 has to cross cancel with the 2 and we need a 3, so it's going to be 3 over 2. So the answers are reciprocals. So our two solutions are going to be 2/3, 0, and the other one's going to be 3/2, 0. All right, so there you have your two solutions for number 16. So there's 16 detailed practice problems on solving quadratic equations by factoring. Keep in mind that you can't factor every trinomial or every quadratic equation, and sometimes you need other strategies, but factoring is typically a pretty good method that if you can do it, you should, and then you should maybe complete the square or use the quadratic formula or something in case you cannot, okay? As always, keep up the great work that you're already doing. If you found this video helpful in any way, please feel free to give it a thumbs up and let me know in the comment section down below. Again, you can also find a free download of this blank PDF, this annotated PDF, as well as a link to the video in case you want to share it with anybody that might also find this useful. And as always, keep up the great work, and I'll see you in the next one.